Okay, this is the last one out of the powered curriculum guide that we need to go over. And this is a pattern of a cone. And we're probably going to do just like we just did with the previous one. We're also going to do a pattern of a truncated cone. So I go back in again, USA, create the part, go to top view, top plane, and we are going to sketch. And we're going to pick it up from the center, create a circle. So all this is an ice cream cone, and call it, say, 7 inches. And then we have to create that gap. So just off of the center line horizontally, and then create that piece and offset it 30 thousandths up. I always like to go up. Okay. Grab that line and do a for construction, and then to finish it up we're going to trim and create that little gap. That's it for the base. Okay. Into features, reference geometry and plane. We're going to select the top plane and we're going to offset it. Let's stay with the 7 inches, equal the diameter. Happy check mark. And if I go to my top view, I'm already on that plane, so I can start sketching. And we're going to do another circle. We're going to go pick up the origin again. It's going to be right at the same center. Pretty small, small as you can get away with. Okay, so I always like to go a little bit big, and then we can always see if we can get away with smaller. All right, and then we need some center lines here. So here, and then we can also pick up the other line that we just created off of here. Save a little bit of time, and trim the closest and get its gap. Okay, and let's save this thing quick. It's just a cone. And let's see if we can get this thing to loft. So we're going to grab, again, I'm going to grab here on the lower side, and I got to zoom in, and also on the lower side. Otherwise you don't get, this way you don't get any weird twists out of it. Okay? And that is the cone. Okay? Radial line development. Radiates from the center being the top of it. So if I take this and flatten, and just grab this surface and go normal to. Okay? You can see, just like in the book, looks sort of like a piece of pie crust or something. Okay? So here's your top, radiates out, and there is your flat pattern for your cone. Let's suppress this. And go back to your isometric view, and we'll save it. Pattern of a truncated cone, okay, is just chopping it off again. So page 424 to basic technical drawing, figure 1818. If I go to my front view and I go into my front plane and I sketch, and then I create just a simple cross here, right? Simple cutting plane, and I'm going to take that and cut through. I'll leave normal cut on for right now. And let's see if she's happy with that. Got to think about it a little bit. A little more complex geometry because you're not cutting through just straight planes, you're cutting through a curvature. And let's see if we can get this to unfold. And again, grab that surface and let's do a normal 2. Okay? And there it is. Alright, now, in the book, this is the way it needs to look on your drawing when you create these. Okay? So you have the curvatures, and then the curvature here looks like a smiley face, sort of. Okay? This one I'm going to show you quickly how I want to see it presented in a drawing. Okay, right here, this is vertical. Okay, so we're going to have to make some adjustments when we get into the drawing aspect of this. So let's go File, New, and we're going to do an A-size USA landscape. Okay, and we're going to do the cone. And the first thing we're going to do is the flat pattern. Okay, so there's the flat pattern. And it's almost in the correct position. Now let's go back to our drawing itself and let us suppress this again. And then we're going to insert a sheet. So again, it says can't find it. Just pick one for landscape, okay. And then here we're going to go up to Insert, Drawing, Model, Cone. We're going to do a front view. See what we get here. Do a few views. Like I said, my preference is to do this drawing shaded with lines. This is how this needs to be presented. Again, from point to point. Okay, because you got to tell me where that cut was. Okay. Where did you come from? Another smart dimension from here to here. Okay, that's where the cut was there. And then we need to know a couple other things, all right? A couple other things that aren't shown. Oh, didn't like that. Let's see if we can grab the points. Okay, so we got the 7-inch. Let's just add in that it's a diameter. Okay, that tells you just about everything you need to know. When you were creating this thing, you had dimensions in mind of where the point got to and things like that. This gives you the overalls. And just save that on a desktop quick. Let's go back to sheet number 1. Like I said, it needs to be presented like this. Okay, it's like a smiley face. So you can grab your views. One thing is this thing could be a little larger. So let's go up to half scale. That's not bad. And then we can grab it and we can rotate our view. So we notice it's about 0. Let's see what 180 does for us. Let's see what another 20 does for us. It goes back to where it was, 180. Let's see what 200 does. Okay, we're doing a little guesswork here. How about 190? Ooh, 190 looks pretty good. Okay, there's your smiley face, okay? And we're going to close that. There it is. Okay, again, the big advantage of sheet metal and SolidWorks is I can take that file, save it as a DXF, and send it off to a customer. And have, or a customer, but say a vendor has a laser cutter, he can use that DXF and cut away. One thing, when you do that, okay, and I'm just showing you this in the last video, you need to put just a few reference dimensions, okay? So when you create this thing as a DXF, sometimes, just like right now, we're not at full scale, okay? So when they import it, one of the first things they better make sure is that they check this point to this point and make sure that it's 15.760 inches, okay? You have to make sure that they understand that they have to check the part to make sure it's the correct scale, that the scale is like, say, 1:1. Maybe they bring this in right now and it's, I believe it was 1/2 that we used, okay? So it's half of what it really is. So they need to make sure that they double their DXF file to match your dimension. Now some of you can say, oh yeah, well this is a smaller part, we could put it on a B size, C size, D size. That's great. What if the part's 20 foot long? Okay, all you're going to be doing is putting it on a D size and then sending that to them. So that's why when you convert it to a DXF, you need to have some just reference dimensions on there so that they know that the size you're looking for is this. Don't scale the drawing. I mean, it always says on every drawing right here, do not scale the drawing. So if that's what they're using and they didn't pay attention to the size, they are at fault. So you have to make sure that they understand that they have to look at the dimensions and make sure the part is the correct size. I've seen this happen in industry. So that's a cone, truncated cone, and how a truncated cone pattern should look, and how some of the basic dimensions are off of the 2 or 3 view drawing with an isometric, and that's the way they should all be turned in. That's it.